Hi, welcome to binary tree postorder tree traversal without using the recursion by using the iteration method with stack. So first we will create the empty stack, then we will check the given tree is empty or not empty. We are passing that root node. If it is not null, then we are pushing that root child, pushing that roots right child into the stack, then root into the stack. First we will push the roots right child c into the stack, then we will push the a into stack. Then we are making a new root as a roots left child. So now the roots left child will become the new root. Then again we are checking root is null or not null. Yes, again root is not null. When root is not null, again we will check the roots right child, is it available or not. Yes, roots right child it is available. Then we will pass into the stack, pass into the stack. D is pushed into the stack, then root is pushed into the stack. So now again the current roots left child is assigned as a new root. So current roots left child is new root. So this is the new root now. So root is updated. Again we are checking root is null or not null. Yes, it is not null. So now we are pushing the d into the stack. Roots right child here, root is d, roots right child is null. So there is no child available, right child available for the d. So this step is not done. Then uh, insert the root into the stack. So d is inserted into the stack, right? Again we are checking the roots left child. So roots left child is again null. So d is the root. So roots left child is null. So now we are checking a root is null or not null. Yes, it is null. So if it is null, we will come down to the third step, pop the data from the stack. So we are popping the d from the stack, then set it is a root. So now we are popping uh, d from the root of d from the stack, then that is acting as a root. So now if we are having the right child for the popped data, so there is right child not available to the popped data. So now what to do? We have to go to the else statement. In the else statement, prints the root dot data. What is the root dot data? D. So d is the data which is printed now. Now setting the root as null. So now we are setting the root as null. So as of now root equal to null. Then again repeat the step 2 and 3 until stack is empty. So now we are checking the stack is not empty. So we are going back again. Now root is we set as root is set as null. You look at here, root is set as null. So when root is null, this condition is false. This condition is false. Then it will come here. So pop the data from the stack. Pop the data from the stack. So b is the data which is popping from the stack, then set which is the root. So b is set as a new root. If popped data has right child, so b we are checking is it have right child. Yes, it is having the right child which is the e. So now the it is having the e with the right child value e equals to top of the element in the stack. You look at that now. Already b is popped up. B is popped in this stage. So this is not available. Now top of the element is e. So now the right child of the right child of the b is e. Okay, right child of the b is e. E is equal to then top of the stack. So top of the stack is here e. So e, so if both are equal, then pop the right child from the stack. So pop the top of the element from the stack. So now we are popping out e from the stack. Then push the root. What is the root now? As of now root is b. Root is b. So push back that b into the stack. Now we are again pushing that B in this location. Okay, B is inserted back into the stack. Then after pushing back, we are setting that root's right child as a new root. What is the root's right child? What's the B's right child? B's right child is E. So E is the right child, so which is setting as a new root. Setting as a new root. So as of now, we are having this is the root. So now we are going back again. We are going back again. So again we are checking root is null or not null. Yes, it is not null. So when it is not null, again we have to check that. So all the steps are explained here. As of now, look at this. We are at the stage of CAB. CAB. Okay, so this is the thing. So current node is now A. Current node is C A B. So now here we popped up the E from the stack, then push back. The root is pushed back into the stack. Now we are checking the right child of the current node. Current node is B. Right child of the current node is E. So this is the right child of the current node. So this is the new root, which is assigned as a new root. Which is assigned as a new root. So now we are checking. Now again we are checking here. Again we are checking here root is null or not null. So as of now, current root is E, which is not null. If it is not null, we have to push the root's right child. What is the root's right child? Null. So we have to push the root's right child, but it is not having the right child, that is the null. E's right child is null. So now due to that we are pushing the root into the stack. What is the root here? Current root is E. Insert into the stack. As of now we are having CAB. CAB. Now E is pushed into the stack. Then after pushing, we are moving back to the root's left child. So now root's left child we are moving. So in the left child also, root's left child also null. So which is also not exist. If it is not exist, then now which is null, we are setting as a null. So now as of now we are having the current stack elements are CABE. So now if it is null, then what we have to do? While we have to check again, going back, root is current root is null. So again we are checking while root is not null, this one, but it is false. So it will come out. So popping the data from the stack. So which is the element? So popping the E from the stack, then right side of root we have to check. Okay, right side of root we have to check. So here when we are checking the right side, so here the right child of the E does not exist. Then if it is not exist for the right node for the E, then we are setting that current node is null. So once it is setting as a null, root node is null, then what we are doing? So we have to print this as per the when our node is null, then this statement will execute. Print the roots data. So this will be popped up. This will be popped up and print in the printing in the statement. Okay, then now root value is set as a null. When current root is null, right? Current root is null. So we are checking again. So root is null or not null? Not null. This will not execute. Now popping the element from the stack. What is the element available? B is available. So which is popped up, then which is set as a root. So now B is the new root. Now we are checking the right side of the B equivalent to the top of the stack. So top of the stack is as of now A. Top of the stack is now A. So which is not matching. B of the right side of the B is E. So which is not equal to the top element of the stack. So just we are printing the B. Then we are setting the printing the B, this statement, otherwise else statement is executing. So set printing the B and set the new root is null. Once new root is null, again we are checking root is null or not null, which is false. Then pop the next element from the stack. So next element in the stack is a. So a is popping up from the stack. Then we are checking right child of the a equals to top of the element. Top of the element is c. So is it top right child of the a is here c. So c is equal to the c. So it is matching. If it is matching, what we have to do, pop the right child. So we have to pop the c also. We have to pop the c also. So now we popped up a and c. Then again pushing back the root is current root is now a. Current root is now a. Current root is a. So a is pushing back into the stack. So now stack is having a. So that's what given here. After uh, pushing back the a, the stack is having the a, right? Then set root as root's right child. So root's right child is, for a's right child is c. So c is the current root node. So now current root node is c. Then we are checking root is c now. Root is c now. So again we are checking root is null or not null. Yes, it is not null. Once it is not null, then we have to check root's right child. So currently root is c. So right child of c is g. So the g is existing. G is existing. So g will be so now as of now, which is having stack only a is available in this step. Then now pushing the pushing the g, right? After pushing the g, root is also going to insert into the stack. So now c is the root. So now c is also pushing into the stack. Then as per the uh, algorithm, this step is over. Second step is set the root's left child as a new root. So root's left child is f. So f is setting as a new root. So here the current new root is f. Now here we are having a, g, c. Now current root node is f. Current root node is f. So now we are checking root is null or not null. Not null. Okay, because it is f. So f, for the f we have to check right child. Right child for the f is null. It is not existing. So which is not existing. So we leave that. So push the root into the stack. What is the root here? F. F is the root. Then move the left child of the root. So left child also here null. So now again we are checking. So what is the root value? Root value is now null. So this condition is false. If condition is false, come to the next statement. Pop the data from stack. So the stack top element is f. We are popping up. We are popping up. After popping the element f, we are setting that as a root. So now f is the root. F is the root. So now here once f becomes root, we are checking the right side of the f. So right side of the f is here null. Right side of the f is here null. So then we are executing this statement. So prints the roots data. So f will be printed. F will be printed. Then set current root is null. So set current root is null. As of now, the stack elements are a, g, c. So a, g, c, right? Then now, so here the current root is null. So if again we are checking root is null or not null, it is null. If it is null, this statement will not execute. False. Now popping the element from the stack. So the top of the element is c, which is popping up. Then which is the new root. So now this is the root. This is the c is the root. So now checking child's value, right child value of c. Right child is g. So g is equal to top of the element. So current top is g. Current top is g. Is it equal? Yes, it is equals. If it is equals, pop the right child from the stack. The right child is g. So g is popping up. Then we are pushing the root into the stack. So now again we are pushing the c into stack, pushing the c back to the stack. So again we are pushing C back to the stack. So now the root's right child is setting as a new root, right? So now G will become a new root. Okay, so now after that current root node is G. Then we are again going back here. The when we are checking this root is null or not null, not null. If it is not null, what we have to do? So here we are at here. So now we are checking the this is having A and C. From here now we are checking current root node is G. So G is checking null or not null. It is not null. So we are checking the right child of the G, which is null. So you leave that. Then push the root into the stack. What is the root? Here G is the root. G is pushed into the stack. Then checking the root's left child. So root is here G, left child is here null. So now root is null. Root is null. Again we are checking. So this statement is false. It will not execute. Pop the data. Right. So pop the data. So this one previous step. This one left child. So now pop the data that set as a root. So top element is G, which is the root now. So root. This is current root. So here we will pop the right child, and that is the we are checking here right child is available or not. Right child is not available. Right child is null. So if else statement will execute, else statement print the root dot data. So G will be printed. Then set the root is null. So now root value is null. Currently root value is null. So current root value is null. As of now stack elements are A and C. A and C. Now again for this again we are checking. So as of now we are here. Again we are checking root is null or not null. Yes, root is null. So this is false. It will not execute. Now stack is having A and C from this step. Then if it is null, we have to pop the element from the stack set as root, right? So top of the element is C, so which is popping up and set as a root. So C is the root. Now we are checking the right child for the C. So for right child for the C is G. Top of the value is in the stack is A, so which is not matching. Just the so else statement will execute. Else statement is root, printing the root dot data. Root is now C, so C will be printed and set root as null. So currently the root will be null. Again we are going and checking root is null or not null. Yes, it is null. As of now we set the null. So since it is the null, we have to pop the element. We have to pop the element. So popping the element from the stack. So that is A. That is A. So here as of now the current node is null. So popping already element available A. So now we are popping this. So once it is popped up, then we have to check the root. Currently we are popping that and we are setting that as a root. Popping the element from the stack, setting as a root. For popped element A, we are checking the right child. Right child is here C. So C equal to then data at the top of the element. So here stack is now empty. So stack is now empty. So which is not matching. So if it is not matching, else statement will execute, print the roots data. What is the root here? A is the root. Here A is the root. What element popped up? A is popped up. That is the root. So printing the A element, and now new root is null. Once it is null, again we are checking root is null or not null, which is null. Then here it will come popping the element from the stack, but stack is empty. So once it becomes empty, we can stop the algorithm. So this is the procedure to do post order tree traversal for the binary tree without recursion. Thanks for watching.